Okay, so this is approximately where we had left off with last time, because remember yesterday we had skipped ahead a little bit because we have benzene on the schedule, and what we had done is we started talking about some of these substituted hydrocarbons, and that could be anything from alcohols, but we did not talk about alcohols. We talked about a different type of derivative. And from yesterday, what was that derivative? You could actually say plural because it's column 7. Yeah, halogen derivatives. So you are now whether you count that as 1, column 7, or you count that as fluorine, chlorine, bromine, and iodine. Maybe you count that as 4. You pick. So I just count them as 1 because they're all in the same column, then ethyl groups, and then methyl groups. Okay, so those are your 3 types of derivatives that we, again, have discussed. But what we see is when we talk about benzene, okay, we drew this up on the board once. Okay, 6 carbons and 6 hydrogens, which is rather unique. Okay. And it's what we call an aromatic compound. Do we have this content here? Okay, so then we had actually continued on, and now we start to talk about, again, benzene. Okay, then I think on the next slide, that's probably where we had started yesterday. Oh, no. Okay. Does everyone have this content that wants this?
No. No, not yet.
Okay, your vocabulary?
Almost done. I just got like a few more.
Okay, yes.
Did I do this part like that?
Well, when we hand it in, we'll find out. How's that? Okay, now does everyone have this content that wants it? All right. So what your books are for is what we're going to be talking about here in just a moment here. All right. So does everyone have this content that wants it?
Not yet. God, more writing plus talking. Ow. Not to mention work. Kelly's distracting me. Don't look at her.
Yeah, John, why are you looking?
She looked at me first. What's that supposed to mean, John? He's a
Like his game, like his friend group, like me.
Okay. Do we have this?
Yeah.
That you, if you want it. Okay. So, what we're talking about here, so if we were to see something like this, okay, those are two different compounds that we see up there. Okay? Can anyone, what's the first thing that stands out in your mind on how these two compounds are different?
The one who's going in.
So what does that mean if there's lines in the middle? In other words, what is the difference between that compound and that one? Okay. So how do you know that it's a double bond? It's got two lines here. So this is propene, or one propene, and this is called what? Propane. Okay? So with that being said, if this has double bonds in it, which it does, okay, what do we know? Where each and every one of these lines intersect, what does that mean to you when they intersect? Okay? Those are carbon atoms at each and every one of these intersections. Okay? So with this one, what would you call that? Because there is one on your paper that's similar to this. This would just be plain cyclohexane. So looking at this, what is the formula for that cyclohexane? How many carbons do you have?
There's 6.
Okay. And how many hydrogens would you have? 12. You would only have 12. Okay? Now, even though this is an alkane, this is another one of those that's an exception to the rule. Okay? This would have a constitutional isomer. Okay? Which, for our purposes, we would call that. The reason that some people may understandably make a mistake and say 14 here, why would that be? Well, what happens when you write hexane like this? What's the formula? What is the molecular formula for hexane? C6H14. And we know that that's hexane. Even though this is hexane as well, how do you think we may have lost 2 hydrogens even though they're both hexane molecules? Well, what happens is when you bend this around, okay, if we were to say 1, 2, 3, 4, 5, and 6, we'll just say this is carbon number 1, 2, 3, 4, 5, and 6, okay? Once you start wrapping them around, you lose this carbon, or excuse me, that hydrogen and that hydrogen. And that's how you arrive at C6H12, because now carbon 1 is now attached to carbon 2 and carbon 6. Carbon 1 is attached to carbon 2 and to carbon 6. So we know that this is a ring structure because you said cyclohexane. But when we look at benzene, okay, what is, see if we can make this see once what this says. Okay. How many carbons in benzene?
6.
And how many hydrogens?
6.
So that is why these are two different compounds because of these alternating double bonds. So we have hydrogens on the outside. 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6 hydrogens. But there is a better way to write benzene than this. So what I mean by that is the same reason. Why do we not put these hydrogens on here? Yeah, it's just understood that those are all going to be hydrogen atoms unless you do something like this. Then you're saying there's something other than hydrogen on there, and that would be a substitution, and that would be correct. You'd have 2-chlorohexane. But rather than writing it this way each and every time, there is a better way, and that is by doing that. These mean the exact same thing. It's just a convenience instead of writing a 6-sided figure, putting these alternating double bonds inside, and then putting all the hydrogens on the outside. So this has a formula of C6H6. So does this one. Even though you don't have the hydrogens on here, it's just understood that these hydrogens are on the outside, just like this is an understanding that on these dashes there is a hydrogen atom. Benzene is a very, very stable molecule. Most alkenes are not. Benzene is an exception to that. Okay? So what I want you to do is open up to page 711. 711, 711. And then if what does this tell you? If a lot of you do this, if you take a book from the back and then after the bell rings, what should you do with your book when you are done? Put it back. Some people leave these on the desk. Why would we do that? I don't know either. Okay? So, on page 711, okay, at the very top, it just says benzene and says figure 8, okay? So benzene shows a special type of carbon ring called benzene, okay? As you can see, the benzene molecule has 6 carbon atoms bonded into a ring. Benzene C6H6 is a cyclic hydrocarbon with carbon atoms that are joined with alternating single and double bonds. The electrons in the double bond are shared by all 6 carbon atoms in the ring. The equal sharing of the atoms is represented by the benzene system, the benzene symbol, a circle in a hexagon. So that is why we don't want to, and I guess if the author says this, we don't write it like this every time. Rather, when you look to the right on figure 8 on page 711, that's why they show you a structural formula, and then to the right, they just show the symbol. Those mean the exact same thing. So it's just way more convenient to draw benzene like this. Now, in case you're wondering what happens the further that you go in this curriculum, you can tell we must be softball players because we're giving signs like this, and that must be our own little language or something. Oh, no, it doesn't mean anything. So then why do we do it? I'm just curious. No, I don't know either. Okay, so what we mean by this, the further you go in this curriculum, okay, the more important that this molecule is. And what we mean by that, okay, is the seniors are going over this right now. It just says, okay, it's talking about a video that we're watching, but they're well aware of this. Don't write this down. Sometimes I do this just to show you that there is a reason why we teach you this content in a specific manner. Okay? That molecule is not just what looks like a complex one, but it's very important because of steroid hormones. Okay? What we mean by steroid hormones, this cholesterol is a building block for this, for this, for that. And a lot of these become more important again as you advance through the curriculum, okay? And all of these are derived from the same parent molecule called cholesterol. Now there's some more aspects on here, but that is what each and every one of these have in common, is that parent structure, okay? But what happens if we do this? If we're going to change this cholesterol, which you do not have to be able to draw, you don't have to do anything like that, okay? But you would have to maybe recognize what this is. It's not dibenzene, but it is on page 711. Naphthalene, okay? So the reason that that is significant is because if you were to, let's say, put totes or Christmas decorations, anything like that up in your attic, these little white spheres that don't smell very good, at least I don't think they do, but you could put them in your box, and the idea is to keep mice out of there. Does anyone know it's something, they're called little white balls? Does anyone know what they're called? You might have heard of them. They're called mothballs. That is this, naphthalene, okay? So as we keep going, fused rings, okay, sharing of these 6 electrons causes the benzene molecule to be very stable. The carbon atoms are bound in a rigid, flat structure. Benzene acts as a framework upon which new molecules can be built. Benzene rings can fuse together like in naphthalene molecule, in a naphthalene molecule. Naphthalene is used in mothballs, which have a distinct odor. Many known compounds contain 3 or more rings fused together. Tetracycline, antibiotics are used on a fused ring system containing fused rings. Okay? Tomorrow we will continue with there's 2 more compounds that we're going to assign to you. Benzene is 1. 2 of them is naphthalene. 3 of these would be called anthracene. And then if there are 3 of them together with 1 on top, then we call that anthracene. Or excuse me, phenanthracene. Okay? But it's just a way for you to categorize these compounds. Okay? So the reason that we got your books out is so we see that, there are reasons why we write these things down. Okay? Because how do you know we're just not making this up? We could be making this up, and would you know any different? I agree. Okay. So, we have some papers that are due. Please get them out. Make sure your names are on them, and I will collect them. So cooperative learning is great, but when we get to maybe sometime next week, if we have a short evaluation over this, who's responsible for this content? Each individual. Like, that's why I'm saying, if you learn from each other, that's great, but don't fall into the trap of just writing what someone else has down. Okay? Do you learn anything that way? Probably not. And then that might show on your short evaluation over this content. Okay, so that's really all I have for the overhead. But what I want to do then is let's look at everything that we have learned so far. Okay, so we can get rid of this, get rid of that. So we've learned 4 organic families so far. What are they? And once you name one, they're all going to fall into place. That 4th one might be a little difficult. Nope, that's a derivative. Organic families that we've learned so far.
Alkene.
That's one. What else have we learned?
Alkane.
Alkane. Okay.
Alkene.
We'll take that. Alkyne. This is where we said this 4th one might be a little difficult. No, that can still fall into these categories. It's a special one of these types of compounds. We just got done with it no more than 5 minutes ago. Benzene, okay? You can say benzene or aromatics. Yeah, really, that's what they are. Okay? Now, the derivatives that we've learned so far. Okay? We talked about that earlier. What are some derivatives that we've learned? That's one. Okay? That would just mean you have 2 of those. Okay? So then there's one, depends how you count these. Whether you say 4 to give you 6 or just 3, because halogens, as we all know, is fluorine, chlorine, bromine, and iodine. So that's how we either say 6 or just 3. Okay? So how do you tell these apart from one another, these organic families over here? How do you know the difference?
Because they've got different bonds.
That's true. They have different bonds.
Last 3 letters.
Okay, so the last 3 letters would tell you quite a bit, which we mean are these. Okay? So in the order that we learned, if it's an alkane, what does that mean with the carbon atoms in between each carbon? How are they arranged?
Single.
Those are all single bonds. Okay? In an alkene, how are those carbon atoms arranged? Okay, you can have multiple double bonds. We don't do that at this level. Next level you would, and certainly the level after that you would. And then what does this tell you? There's a triple bond located somewhere. Then how do you know that you're looking at benzene and not a ring structure? Because for our purposes, okay, if we were to name any ring structure, which we could even do this, okay, that is a ring structure, okay? You could draw it like that, and on your paper, it was actually drawn like this, which still means the same thing. No, that's not right. Should be like that. Oh, there we go. That's the problem that we have. Okay? So how do we know how to name this? It's got 4 sides, so the parent chain is 4. Is there any multiple bonds in there? No, because it's saturated. So we could call this what then? Cyclobutane. Okay? Then once we start throwing these in here, okay, what could we call that?
It's methyl.
It's a methyl group. That's right.
It's got CH3.
So just like every other problem, we want to find your parent chain first. Okay? So how many carbons are in this parent chain? So we know this is our prefix. Is it saturated or unsaturated? Okay? Is there anything branching? We need to be a little more specific than this too. Okay? And then there's maybe one more thing that we could draw. We've got cyclo on there already. Okay? So do we have to be specific with where that methyl group is? So the answer to that is no. Unless we were to do this. Then we can't just leave this as methyl cyclobutane. It would be 1, 2 dimethyl. Okay? You know, if we put some oxygen atoms on there, maybe 1 here, 1 here, and 1 here. Look, we won. We're all winners. We're all winners. All right. Is that what you thought of when you saw this too? Is it kind of reminds you of tic-tac-toe? Okay. All right. I suppose I could have put X's in there, but there's oxygen atoms. There really is no X up there unless you're putting xenon on there. Yeah, we're not going to do that. But yeah, so we got these 3 oxygen atoms floating around. So, we won. All right. So that's all I have. We'll continue with this benzene system tomorrow, so we'll catch up to you next time.